Welcome to this explainer. Okay, picture this. It's the late 1700s, and the study of geography is basically just a messy pile of travel diaries and mapped coordinates. Fast forward just a few decades, and it's a rigorous, highly respected foundational science. So, what happened? Well, between 1769 and 1859, our understanding of the world was completely turned upside down by two German contemporaries, Alexander von Humboldt and Karl Ritter. Get ready, because their incredible journeys, both trekking across the globe and lecturing inside the university, literally built the framework for how we study the Earth today.
So, let's dive right into our roadmap for today. First, we'll introduce our two giants. Then, we'll follow Humboldt the explorer and see how he synthesized his wild findings in his masterwork Cosmos. After that, we'll shift over to Ritter the academic, unpack his masterpiece Erdkunde, and finally, we'll explore their combined global legacy and the institutional development of geography.
Section 1. Two Giants of Modern Geography, the Adventurer and the Academic.
To really understand the birth of modern geography, you kind of have to look at it as a buddy cop story of science. We have two guys living at the exact same time who took entirely different paths to build the exact same discipline. On one hand, you have Alexander von Humboldt, the ultimate empirical adventurer. His method was highly field-based and inductive, meaning he went out, gathered massive amounts of raw, on-the-ground data, and then used that to form broader theories. And this brilliantly illustrates the contrast with our other guy, Karl Ritter. Ritter was a teleological, holistic thinker who favored a deductive method. He stayed academic, building the theories from the classroom, taking existing data to understand the Earth's ultimate purpose. Basically, one shaped the field by climbing freezing mountains, while the other built university departments.
Let's kick things off with our adventurer. Section 2. Humboldt, a great explorer, the empirical field scientist.
I'm not exaggerating when I say Humboldt's life was like an epic movie. He was born into an aristocratic family, but in 1797, he actually gave up a super stable, high-ranking government mining job just to dedicate his life to exploring the physical world. Armed with incredibly heavy equipment, think barometers, thermometers, sextants, he just set off. And his journey was relentless. In 1798, he was traveling through the Spanish Meseta, constantly logging temperatures and altitudes. By 1800, he was deep in the harsh, uninhabited regions of Venezuela exploring the Orinoco River. He literally almost starved to death in the wilderness there, but he did it to successfully prove its geographic connection to the Amazon River basin. In 1801, he moved on to the Andes, Colombia, and Ecuador, studying volcanoes and how altitude impacts crops and vegetation. And decades later, in 1829, he pushed into the completely uncharted territories of Siberia and the Ural Mountains.
But to truly grasp Humboldt's sheer dedication, we just have to look at this number, 6,326. That is the height in meters of Mount Chimborazo in Ecuador. During that 1801 expedition, Humboldt and his team climbed this massive peak, which, fun fact, was actually believed to be the highest mountain in the world at the time. But he wasn't just climbing for bragging rights. Humboldt courageously used his own body as a scientific instrument. As they ascended to 6,326 meters, he meticulously recorded the effects of high altitude on his own physiology. He documented his own altitude sickness, the air pressure drops, and vegetation changes at different elevations. It was extreme empirical science in action.
Next up, Section 3. Cosmos and Principle of Wholeness. Synthesizing the Physical World.
So all that extreme fieldwork wasn't just him being an adrenaline junkie, it generated an absolute mountain of data. And from that data, Humboldt began synthesizing entirely new scientific terminology. For instance, he coined the term continentality. The crucial point here is that before Humboldt, people obviously observed the weather, right? But Humboldt introduced a rigorous regional analysis to describe how temperature, humidity, atmospheric pressure, and wind speed are distributed across land masses based entirely on their distance from the ocean. He practically invented the way we map climate.
And here's another term you're definitely familiar with, permafrost. When Humboldt traveled to Siberia in 1829, and by the way, he went at the direct invitation of the Russian Tsar to explore those untouched lands, he rigorously studied the frozen earth. He needed a brand new word to describe soils that remained permanently covered in ice and frozen year-round, so he coined permafrost. It's a concept that is absolutely central to modern environmental science and how we understand global climate systems today.
Humboldt culminated his entire life's work into a famous multi-volume masterpiece called Cosmos. The first volume dropped in 1845, and he had 4 massive objectives with this work. He wanted to define the physical boundaries of nature, discover true scientific objectivity, inspire an emotional connection to nature, and explain the history of natural philosophy. The overriding theme of Cosmos was his principle of wholeness. This is the idea that nature and human origins share a common source, and that we have to view the Earth as this deeply interconnected living entity, not just a bunch of random isolated parts.
And that brings us to our second giant, Section 4. Ritter, father of academic geography, institutionalizing the science.
Now, Carl Ritter was actually 10 years younger than Humboldt. They met in 1807, and Ritter honestly viewed Humboldt as a bit of a guru. But Ritter took a completely different path. The real turning point happens in 1820. This is when Ritter became a professor of history and geography at the University of Berlin. Now, what's really interesting about this is that by doing this, he essentially took geography out of the harsh wilderness and brought it indoors. He established Germany's very first organized university geography department, transforming what was mostly a hobby for wealthy explorers into a highly structured, formal academic discipline.
To really get Ritter, you have to wrap your head around his core philosophical approach, which is the teleological view. While Humboldt was out gathering data to see what patterns inductively emerged, Ritter approached geography with a really deep belief in divine providence. A teleological view is basically the idea that natural events and physical geography should be studied based on their inherent purpose. Ritter believed there was a harmonious, purposeful order in nature that was designed specifically to support human development.
That specific worldview built his legacy. Section 5, Erdkunde, Science of the Earth, Ritter's 19-volume masterpiece.
The Earth is made for man, just as the body is made for the soul. Isn't that a wildly powerful statement? It perfectly encapsulates Ritter's holistic, teleological worldview. For him, you couldn't just study rivers or mountains or climates in isolation. You had to study them as a complete organism whose ultimate, divinely ordained purpose was to serve and shape humanity.
Ritter poured all of this philosophy into his own masterwork, Erdkunde. He published an astonishing 19 volumes between 1817 and his death in 1859, focusing heavily on the regional geographies of Asia and Africa. In doing so, he built the foundational concepts for academic geography as we know it. Let's look at how this builds out. He argued that geography is an empirical science and that there is a spatial harmony in nature. He taught that boundaries, like rivers and mountains, are tools for discovery, and that the Earth must be studied holistically in its totality, ultimately driven by a divine source meant to meet human needs. These points literally became the bedrock of geographical curriculum for generations.
Moving to our final section, Institutional Development of Geography, a Global Legacy.
Ritter didn't just teach students. The guy was a brilliant organizer. In 1828, he founded the Berlin Geographical Society, and this sparked an absolute explosion worldwide. Over just a 30-year period, driven by Humboldt's wild discoveries and Ritter's academic structuring, we see the founding of major geographical societies popping up in Paris, London, Mexico, Frankfurt, Brazil, Russia, and America. Together, they created a permanent, institutionalized global network for sharing scientific knowledge about the Earth.
Ultimately, the legacy of Alexander von Humboldt and Carl Ritter is that they gave us two incredibly powerful lenses through which to view our world. One gave us the rigorous tools to measure the Earth, and the other gave us the academic framework to ask why it matters to humanity. So as you continue your own journey of learning, I want to leave you with this provocative question to ponder. When you approach a complex new topic, are you an inductive explorer, gathering every piece of raw data you can find in the field? Or are you a teleological synthesizer, looking at the big picture to find its ultimate purpose? There's no wrong answer, but combining both just might change the world. Thanks for joining me on this explainer, and keep exploring.